Welcome to Factual Facts on the Mole Network. My name is Joshua Coos, and I'll be your stunt dummy for today.
And I am Katie Wall. I will be your host and MRI technician.
I'm Kyle, and I'm filming this.
Okay. Today, we will be discussing magnetic resonance imaging and why it is so important. What are you doing? Oh my gosh. When someone receives an injury that cannot be diagnosed by a doctor, an MRI may be necessary. Magnetic resonance imaging is a medical technique that uses a magnetic field and the resonance of atoms to provide an image of human tissue. MRI images are much more detailed and informative than X-ray images. And in addition, the process does not use ionizing radiation, which could potentially harm the body. Where did he go?
Ow!
Where did he go?
Ow!
The patient lies on a retractable platform and is brought into the machine. Inside the machine are magnetic coils. The patient is scanned with the main magnetic coil and emits radio frequency pulses targeted at a specific region of the body. There are billions of hydrogen atoms in the body which rotate on a natural axis. When the main magnetic current is introduced, the atoms align to it like a compass and spin on a new axis. The frequency of their new spin rotation is called the Larmor frequency, which is the precession of the magnetic moments of electrons, atomic nuclei, and atoms about an external magnetic field. In order to create a strong enough magnetic field to perform an MRI, the coils of wire must have no resistance. Therefore, they are bathed in liquid helium at a temperature of 450 degrees Fahrenheit below zero. This allows the coils to develop magnetic fields of 1.5 to 3 Tesla, which is the strength of most medical MRIs, and is also more than 20,000 times stronger than the Earth's magnetic field. Once the affected area is magnetized, 3 additional gradient magnets are activated. And they have a very loud sound. These alter the field of the main magnet along one axis, thereby creating a magnetic slice through the body. These slices allow a specific part of the body to be viewed. One magnet selects the slice, and the other 2 read data up, down, and across the slice. The slice is then divided into a grid. Each tiny box is called a voxel. The gradient magnets make the hydrogen atoms flip back once again into alignment with the main magnetic field and emit radio waves. When the magnetic force from the gradient magnets is removed, the atoms return to their natural alignment. As they relax or reach their equilibrium distribution orientation, they emit energy and act as a small radio transmitter. All right, Josh, you're done.
I'm done! Yes! So what's wrong, Doc?
Well, different tissues release different energy levels, and the computer recognizes their distinct pulses. The difference in energy is determined by an atom's realignment time and the density of the hydrogen atoms. Dense tissue takes longer to realign than soft tissue because there is a higher concentration of hydrogen atoms in each voxel. When the computer receives different energy levels, it creates an image which shows dense areas as white and less dense areas as black.
What's that all mean?
Alright, Alright, so here's your image. It looks like you have a swollen brain.
Swollen brain? Cool. I'm gonna go do some chem homework. See you later.
Bye.
Bye.
It was April the 41st. Being a quadruple leap year, I was driving in downtown Atlantis. My Barracuda was in the shop, so I was in a rented Stingray, and it was overheating. So I pulled into a Shell station. They said I'd blown a seal. I said, fix the damn thing and leave my private life out of it, okay, pal? While they were doing that, I walked over to a place called the Oyster Bar, a real dive. But I knew the owner. He used to play for the Dolphins. I said, "Hi, Gil!" You have to yell, he's hard of hearing.
Think I had a wet dream.